Hello guys, and welcome to Make You a Roguelike in Haskell video series part 4. In part 3 I had some technical difficulties, and as I said while doing the video, I had unusually high CPU load, and in the end my video ended up being full with graphical glitches. So I've done a different video where I just ran through all the code that I wrote and explained what I did. So in this video, again, we're gonna start with just showing where we are and what did we do, and then we're gonna hopefully talk about what kind of roguelike we're gonna make. So this is what we have so far. So we have ability to move, and we have some basic collision detection, and ability to load maps from file. As you can see, this is some building. We have no line of sight or anything. What we've done with the code is basically we've created a tilemap class. We created a tilemap data type that we load from file, and we simply use the amount of new lines to calculate our width and height. We pass in a function that takes a character that we put in our file, and we convert it into any type that's gonna be carried around as data in our tilemap. And our data type is now this enumeration of 3 value constructors for floor, wall, and doors. The type variable here marks the type of the type of a drawable we're having, and in our case we're just using a character again. Okay, so as you can see, our map that I drew, it looks very much like some kind of an office. Well, it doesn't really, but it looks like a building. And I was thinking, this is something that I just started drawing because I do run an additional project on the side, a different roguelike that actually I could show you. Let's do that. So I'll run. And this is actually supposed to be a cyberpunk roguelike with all the cyberpunk goodies, you know, like your augmentations, your cybernetics prosthetics, with stealth. You're gonna have a team, and I'm trying to build it on top of Bloodnet. This is an old game. As you can see, this is my office test suit with line of sight, and there's a camera up there. If I stay in camera view, I'm gonna press dot to wait for time. The camera, as you can see, is increasing the amount of time that it has seen me, and if I move away, it's gonna start decreasing. But if I stay in its line of sight, eventually it hits the alarm. And there's another camera here. Alarm obviously doesn't do anything so far, but I've come to a point where I can do these interesting things and maybe interacting with things. I want to show you my conversation system, which is all that we will eventually build. There you go. Eventually we will build for the roguelike we're working on. So this is my bar map, you know. There are, as you can see, there are other characters here, and you can try to talk with them, and they're gonna basically tell you to go away. The bartender has somewhat larger conversation tree, and see you have like typical choices. And you can examine anything. You can check your location. As you can see, it's a pretty complex roguelike so far, but it doesn't have a lot of content. So what I want to change is, because I already have this SF type SF/cyberpunk type of roguelike in a modern setting, I'd like to create something that's more fantasy based. And I've had this idea of a roguelike where you play some kind of alchemist / wizard apprentice, and the roguelike happens in a period that's your final test. Basically, you're put in a forest and you just need to survive and practice all the spells that they taught you in university for a certain amount of time by collecting ingredients, making yourself different potions that give you different abilities. And with these things, by the end of certain period of time, you would have a test where you have to actually mix potions they give you, and if you succeed, now you're a wizard, an alchemist. So one thing which I want to do is we do have the ability to load the map tiles, to load the maps, but I want to start generating as soon as possible. So let's start with our map generator class. There you go. Okay, we'll need tile map. And generate. Generate is gonna take width and height, and it's gonna produce a tile map of some objects. Let's do this. We're gonna do the same type of function we have. Basically, we're gonna produce characters and then return a type of object, so it can be chosen from the outside. If you remember, width and height are our data. Are our data aliases we set up here in tilemap, so they're visible. So the answer is going to be, let's say, generated width, height, and data. Where the data is going to be, let's just make something that looks like grass for now. Sure. Repeat this and then take width multiplied by height. We will need a vector because tilemap, if I recall correctly, takes a vector, not a list. That is correct. From list. And one more thing, we actually have to apply our object function. Let's just call it f. Fmap f. Let's do it here. Because we are lazy, I mean, the language is lazy, we can apply this function to the infinite sequence and just take whatever we need. Okay, and then in our main, let's try to use our generated map. No loading. Let m. Let's say a map 40. Actually, you know what? Let's generate a map that's as big as the screen. See screen. Okay. My code completion still doesn't work. The reason I'm gonna import this as qualified is because the function generate it kind of doesn't say much. So I just want to have more, when anybody reads the code, I wanted to have a bit more insight about what generate is doing and where is it coming from. Screen size, I think this returns a tuple of width and height. So width and height, and our function is gonna be a tile from character, just for now. Obviously we're gonna have to do different types of tiles there. So make program. Nope. Okay. Integral. I understand. The problem is that take, I think, wants an int, right, and we're giving it a word. So let's do this. Let's multiply two words and then convert them into something that take wants. Hmm. 75. Right, so, and this function here, it actually returns two ints. So we need to convert them back into integral, back from integrals into the words. I know it's a bit of a hassle, but we can do this a bit nicer. We're never going to use these two as ints, so they don't need to exist as ints. What we will do, we're gonna import bfunter, and from here we need bimap. And the tuple instances the bifunctor, so that it can be applied. It can be applied to both first and the last element. So these two, when this function is executed, these two are not gonna have a concrete instance, but they can become anything that instances the num type class. And right here, we immediately use them as word data types, so they're gonna become word. This is how the type inference works, right? Nice. So basically, I launched REPL just to see what's the cursor's function, but it seems it was screen size. No, I guess it's a bit too big. Okay. I don't know. Let's try a bit smaller. Okay. It can't work. We can't do -1 here because these are words, and -1 creates works with integer. So we're gonna do this. We're gonna use them while they're integers. We're gonna subtract 1, and then convert them into integral. No. Do we use negative? Yes, we're using negative literals. Okay, so let's use subtract. Again, let me just verify something. 5 from 1. Okay. In subtract, the number that you are subtracting with is going on the left side. This is frustrating. Okay, I don't know why this is not working, but I'm not willing to spend time to toy with it, so let's just make a square tile and move on. It's a question mark, obviously, because we don't have a comma anywhere here. So we are giving a wall type of object with a question mark. So we're gonna be extending this. These styles are probably gonna change, but for now let's do this. We're gonna have a grass with any character. It could be floor, but I want to keep it as a grass because I want the difference between the grass floor and let's say wooden floor or stone floor, simply to know for the future in case I want to do something like setting a floor on fire or something. I want to use this as the grass element, but that means it can't be a door anymore. So doors. How about doors? We're gonna change to slash. And I guess we can use quotation marks. Floor. This kind of looks like a rock, I want to say. So we're gonna make a new rock object. Drawable from tile. We're gonna say that everything else is walkable. All right. Ugly grass. So let's make our generation a bit nicer. Let's do grass tiles, list of characters. Well, basically, this is basically a string. We're gonna use this. I don't like this. Let's do it like this. So we're gonna use comma. We're gonna use quotation mark, single quotation mark. That's it for grass. We're gonna use some rock tiles. And the reason why I'm separating the rock from strings because I eventually want to be able to pick up rocks. Okay. So I'm gonna just build a very uniform map to begin with. Generated data. Generated data. So cycle, grass tiles combined with rock tiles. And this should just create a sequence that keeps repeating. Beautiful. Now let's give it some randomness, and for this we're gonna need some extra code. So we need import monad random. Excuse me. Get random R just gives you a random number in certain range. And this function is now gonna be a monadic function. There you go. This means that back in main, this isn't a let anymore. It becomes this. And this works. Now notice that the type here is IO, and then we run curses immediately. So this whole do block is of C curses type, right? But curses instances monad IO. So inside monad IO, you have a function called lift IO that's right here, which makes any IO function lift into this type, right? One reason why this works, even if this is monad random and not monad IO, is because the IO type instances monad random. So we just need to lift this, and this should just work. And of course, right here, we cannot return just tilemap. We need to make it into a pure. Okay, so the reason why we need to add random package, and I think it's called monad random. No? There you go. I'm just going to verify the time. We're 20 minutes in. That's nice. Okay. So this is still perfect, working very fine, and we can try it just to prove to ourselves that it's working great. But now, instead of cycling our data, we will join these as our samples, and we want to cycle. Okay, we're gonna cycle a function that picks a number at random from our sample. Okay, so let's work this through. Samples, and we're gonna cycle a function that's gonna be get a random R between the first index and length of samples -1 and the last index. And then we're gonna be using this number to pick from samples. Okay. And because this is pure, this is a bit, so we can do some reductions here. First we can remove the pure, take this as a function and just fmap it here. Oh, there you go. No need for monadic code at all. And second, because we can ETA reduce the I out, and we just end up with this. Sweet. So this cycle is going to create a list of functions that get a random number and then pick a random element from our samples. And because these functions won't execute and we want to give out things, we just want to sequence them. Good. Now this becomes type M and list of characters. So let's start executing this in a do block just to make it easier for ourselves. There you go. And then let D, and this should work just fine. No? Set type char with type M char. But there's the sequence. Yes. What's the problem? Okay, so he thinks cycle. Yes, it's not cycle, it's repeat. Sorry. We want to repeat this forever and then sequence, and then down there do the F map on it and take as much as we need. Not deduce monad random. Oh, this is a tuple. It's not two functions, it's just a tuple for a range. Okay, there you go. We don't need a bimap here. This should be a very random map now. Fail. No. There. And this is a block. I wonder if the problem is that the sequence actually isn't lazy, so it keeps working and generating this giant map, and we need to move this much further into the list. I wonder if that's the actual problem. That's okay, we can do this very differently. We can, instead of creating an infinite sequence, we can just create exactly as much as we need, and we'll do it like this. We're gonna start with create all the indexes from 0 until the size we need. So this state is useless. And then we can do this, but this sequence of effects over the list of indexes, we can just, you could use two functions. You can use mapham, which maps monads, but traverse is coming from the traversable type class, and it's weaker. It requires only an applicative, and we don't need any monadic code here. So applicative is, I mean, all monads are also applicatives, right? And use generally when you can, if you can use a type class name, that's it's better. So let's see what we do. With char. With the char. All right, we get an index here. but we do not care about this. We don't do anything with it. Okay, are we gonna get the random map now, please? Thank you. As you see, it's still a very ugly map, and for some reason there's like an extra element here. I have no idea why, but it's okay. So the next thing on the list is, because not all elements in the map are equally distributed, we want to have, for example, much more grass than we have rocks. We need to add a way to have non-uniform distributions of all the map elements, and then use this when we're picking out stuff from our samples. So let's do that. Actually, how are we gonna do this? We're gonna create a new type. This should probably end up in some external module. PDF of any object is gonna be PDF. Let's have ability to unwrap it. And our probability distribution function, it's more like a discrete function. So it's gonna be a list. No, it doesn't have to be a list. It needs to be a set of float, which is your probability of appearing, and an object. And let's add some show here. Let's include set. There you go. And when you construct this, I want to immediately normalize all the values. So I want a smart constructor. But that means I need to move this in another module. Float a PDF of a, and create PDF of lists. We need to do PDF over normalize data. No, we're gonna fmap. No, because fmap on the tuple, it executes only on the second element. We don't know what it is, and that's great. So we again need a bifunctor here. And we don't need a bimap, we need first. First, normalized value. Let me just call it normalize. Over list. There you go. Some ETA reduction. And normalize is gonna take a value, which is a float. We can't. We need to remove this. And this float, we're gonna divide it with from integral, because we need to convert it into a float. Offset size of, oh no, not size, of length of L. So we divide every element, every first element with the length of a list. PDF. There you go. So we took away ability for anyone except this module to create raw PDF, and we can only create it by normalizing the values and then unwrap it. Good. PDF. So our uniform distribution is going to be a PDF of characters. We're going to create a PDF, and our list is going to be equally assigned probability to a merge of grass tiles and rock tiles. Okay, so this is going to be a list of all of our elements, and we want to fmap to this list a tuple with a value 1. This means that every element, every character is going to have equal probability of appearing in our PDF, and then PDF is going to normalize this and put it to be so we have 4 elements, 0, 25. And now we have to use this. This function is kind of looking iffy for now. I want to extract it down where pick character. There you go. Traverse with constant pick character. The interesting part is that we could probably, we could use this as a seed for our, somehow use this and, I don't know, it would create like a really crappy random distribution. Forget, do get random. Okay, we can't see samples, so we need to pass samples. Or no, we don't. We actually need to get uniform distribution, and we don't need these samples anymore. And get our PDF character. Let's set up a type, monad random. And we're gonna get a random character. Oh yes, and we get PDF of characters. Great. So the first thing we do, we're going to get our set out, PDF set, unwrap PDF. This because this is a set, it's not a length anymore. Now it's a size. Oh, and one thing I forgot. Right here in creating a PDF, this will fail for very simple reasons. So we're storing stuff in a set, and that means that all elements in the set, they have to be ordered. Ord A. There you go. This is one of the reasons, for example, why set set cannot implement a functor. Also here we need to convert list to a set. So s from list. Yeah, totally missed this. From list. There you go. And here generate. We know we're passing a char in and all of this, so we're fine. So size of PDF set -1, and we're gonna get an index. We're gonna just do, we're not gonna use the distribution for now. I just want to like merge it with the current PDF code so that pure sample size and work this step by step. Yes, no. PDF set PDF set, we need to unwrap it into a list, set to list, and then pick from it, okay? Boom. Could not find module data set. Right, and the reason for that is because set is not part of a prelude, it's a part of a containers package. Cabal install. Variable not in scope. I told it it's a part of by functor. That's weird. Functor by map first, second, it's right here. What's your problem, man? Oh, okay. For data by functor first. Okay. Could not match type. Something double with a list. Type something double float. No. Okay, this is a mistake I've done. Because I'm applying first on a list, we want to fmap over a list and then fmap over the tuple in a list on a first element. There you go. Sure. The problem here is, as you can see, I've used something that's called a tuple section. Basically, I use the tuple, omitting the second element, and just leaving a comma. This creates a tuple function that fills the second element. Now, the proper way of doing this would be like this. But I find this to be less readable than this. So we need this tuple sections. And this lets you create really cool stuff. Like you could write a triple by doing this, and let's say comma and string blah blah blah, and it's going to be a function that fills this element here. Okay. As expected. Sure. To list, and we just need to make sure that this list only returns the second element, because we just need a character for now. There you go. Okay, so this should mesh nicely with what we have and get a random map. Perfect. And now we're gonna do our non-uniform distribution. First, let's store this on a side. Let me just check the time. 45 minutes, and I think I can pull this off quickly. So we're gonna get a number between 0 and 1, and this has to be a float. And now, in order for this to be a float, I think I need a type signature that looks like this. But the problem is that this m does not refer to this variable here. In order for it to refer, I need scoped type signatures and an explicit for all for this type variable. But I'm just going to leave this for now as it is, and let's see what it does. So we're going to get 1. We need to use, we're going to convert. Can we find things? No. We could find things in a set, but we need a list. So we're going to convert our set to list again. So, by the way, the only reason why I'm keeping it as a set is it's a stupidity. So I wanted to make sure that we don't have copies of A elements in a list. But you know what? That's actually not going to work because it calculates equality for the whole tuple and floats. Anyway, overthinking in a bad way. We don't need a set here whatsoever. Set. Unwrap. Goodbye. Okay. So we got our random number. There's a function called find index, I think. Index. No, it's in data list. Find index. I think it finds you. There you go. It finds you the first index in a list of elements that follows a predicate. And what we want to do, we are first going to sort. We should probably do this inside the PDF. Right? Yeah, we should. We're gonna sort and sort by, compare ordering. Great. Sort by probability order. So we're gonna get the first tuple, and this is gonna be P1 with one object, P2 with a second object, and we need to return P1 compare to P2, and I think compare function returns the ordering, right? Sweet. So we're going to order them from the smallest probability to the highest. That's what we want, right? Yes. We need import data list, and we need sort by. I don't know where compare is. It's probably in prelude. Okay, and then here we want import data list. Find index. So remember, we want to find find index. We need the first index in a PDF. Well, it's not PDF set anymore, but let's just leave it. We can also do this. Or we could use view patterns. Yeah, let's do that. Lang view patterns. Unwrap PDF that maps to PDFs. There you go. And we want to find an index whose first is gonna be bigger than our number, and this is gonna return us a maybe index. We're gonna pattern match on this. If it's just index, we're gonna return PDFs of this index. Am I correct? Yes, I am. If this returns nothing, we should return PDFs. I'm torn between returning some kind of an error or returning just a default. There you go. I like when there are errors and I don't know what's going on. Open. Sure. We should probably do this a bit better. There you go. Except now they're not probabilities, they're tuples. Okay, and what did we do wrong here? Could not match. Did I do it wrong? It's float and A. And here it thinks I want it to be I think I just need to actually apply a function without the name. There you go, great. Could a match expected type in with type maybe in a pattern? Say what? In the pattern. Oh, all right. Because I'm shadowing this name over here. So let's just call it index. No, that's wrong. Okay, this is not a monadic function. My bad. There you go. Okay, and here oh right, so we have to pure here. Why I put pure here instead of downstairs? Well, I just want to prevent this thing from causing side effects. Could not match type floats char with char. Okay, yes, we need first or no, second. We want a second. Now we want a character. Bingo. This should again look exactly the same, but it's now using, oh wow, there's a whole lot of missing in the indexes. Okay. What did I do wrong? Oh, I know what I did wrong. The problem is, okay. The problem is that this distribution is just, they're all 0.25, 0.25, so, okay, I'll explain. When I normalize, I create this list, and in this list, the elements look like this, 0.25 probability for grass, and we have 0.25 probability for rock. The problem is, and let's say 0.25 probability for whatever else we did, flower, I don't know, it doesn't matter. The problem is that the distribution should look like this, 0.25 for grass, and then 0.50 for rock, and 0.75 for flower. this still means that the probabilities are these are the probabilities, but in order to convert it into the representation that we can pick from, because we, as you can see, we always pick the first index that's just bigger than the number we pick. This is the numbers we have to do. So we're going to do a little conversion here, and unwrapping. We have to convert our probability distribution function into I think it's called continuous distribution, but don't call me for that. So we're gonna do CDF, a list of floats and objects. We're gonna convert it into a list of floats and objects. And this is a really undescriptive type signature, but we know what we're doing and what we're gonna do. Every element in the list needs to add the probability of the element before it. And you know what? To make sure that we have normalized elements, we can actually require a PDF. And then right here, I don't think we're gonna need view patterns, but we will just pass the PDF into our function, right? Yes, that's exactly what we're gonna do. Right here, find index from to CDF, CDF from PDF, and right here we're not gonna be sorting anything, so we can just unwrap PDF, right? And pick an index out. Good. And to do a CDF, we're gonna unwrap PDF, and we're gonna map over it. Our map is gonna get a tuple of factor and object, and this is gonna return an object and a factor summed with the previous factor. Should I zip this or just use a fold? Zip or use a fold, zip or use a fold. Zip. I just want to verify how zip works. Let's say we have a list that goes from 1 to 3. And then list that goes from 1 to 3. Good. So it's gonna just take the shorter of two lists, will it? Yes. Good. Okay. Let me do this. Let unwrap PDF. Data is gonna be zip of UPDF, and then drop 1 from UPDF. This way we're gonna get a tuple of next and previous in data. So this is the current tuple, and this is the next tuple, and we're gonna return this by taking, okay, no, we're gonna do this UPDF and attach something that just has 0. Yeah, but I can't create a number here, create an object here. On the other hand, I don't need to sum the first element. It's just all the subsequent ones, because the first always starts at 0. So what I could do, okay, what I could do is this: drop one from here. This is going to be the tuple we're modifying, and take all the previous elements. So our tuple and our previous, and our first value of our tuple element, we're going to sum with the first value of the previous element and just carry the object of the first tuple. Good. But then to this list, we're going to attach the head the head of our original PDF, and this should be fine. I'm not happy about this head, because if you pass in a PDF that has an empty list, it's gonna be kaboom. But we could probably do this here in case somebody passes an empty list. We're gonna return what? Trash. Is it okay to have an empty PDF? I guess it is. Maybe not here, maybe here. Yeah. Like this. Okay, let's get our view patterns back. So here, if unwrapping matches to an empty list, let's just, this is so ugly, and I should probably do this in a different way, but for now it's going to be empty PDF. Not what I wanted. So we don't need, oh, no. We don't need the unwrapping anymore, just the, well, this is, there we go. Okay. And the second argument of this, right, because we just, no, why? What's the problem? Couldn't match type of float AB. No, but it's not. Right. It's tuple of tuples. There you go. Pattern matching, non-exhaustive. Oops. There you go. Okay, so this should work exactly the same way again. Oh, with some again missing data. I just don't know why is it giving me the question marks. Okay, well, I'll fix that bug next time, but now I just want to create a non-uniform distribution just for a test. Distribution, and we're going to create a PDF where our objects are not equally distributed. So we have, let's say we want a lot of grass tiles. Let's say tiny bit less of this kind of grass, about equal amount of this kind of grass, and few rocks. I'm really confused with nothings. I think the issue is somewhere here. Let's quickly debug this. M plus PDF and map generator. So uniform, okay, let's remove all this because we want to get everything out. So uniform distribution to CDF. There's your issue. Okay, right. It's summing only the first, of course, because it's just picking up the previous. This isn't going to work this way. We need a sum of all previous ones, not just one previous. Okay, we can do this. Let's scrap this. So UPDF and we have map. We get a tuple of a factor and an object, and this is going to become an object. And the factor is a factor plus all previous. And to get all previous, we need to know its index. I think there's a fold with an accumulator. T fold. No. No. I have an idea how to fix this, but it's not pretty. But you know what? We can do this. We'll do that. Okay. It's not a map. It's a fold from left, and it's going to be a straight fold. It's going to accumulate an accumulator and a list. An accumulator is going to start at 0. Okay. So here we're going to have accumulator, our result list, and here we're going to have our tuple that consists of a factor and an object. And now the result is going to be accumulator plus factor, and in the list we're gonna prepend, append a tuple of accumulator plus f and the object. Is this correct? I think it is. And then the exit is just going to be a second because we just want this list. This is really much not pretty. But it's probably going to work. And if it's not, stop. Okay, so to CDF of uniform distribution. There you go. to CDF of our test distribution. Bingo. Main. Well, we still get these question marks, and I have no idea what they are. I wonder if just sometimes we pick an index and there's nothing bigger than it, but that makes no sense. What if I lower this to 99, which is really crappy thing to do, because if the distribution actually has it, it's never going to get picked. But I just want to see if it fixes it. No, it does not. Okay, well, I gotta admit, this is confusing to me, but I'm pretty sure that the issue is somewhere around here. Anyway, for now, we're gonna end this, and next time I'm gonna try to fix this bug of getting these question marks, and we're gonna add some color. So thank you for watching, see you next time.